Another graph you might see commonly in like a newspaper or a magazine or online would be what we call a stack plot. Stack plots you have to be very careful about reading. I did this one in colors of gray. Usually online they would be in color, so you'd have one color for each of the bars. But what we have here is the revenue for two store locations, maybe owned by the same company, from the period of time from 2017 to 2022. Now, store B is the lighter part of the bar, and store A is the darker part of the bar. So we've got a bar for each year, and that bar has both a light and a dark region. So again, the light and the dark region refers to which store the revenue is for. The revenue is in thousands of dollars. The way stack plots work is that one piece of information is stacked on top of the other. So store A's revenue comes first in the bar, and then store B is stacked, revenue is stacked on top of store A's. So the total height is going to be the sum of the two stores' revenues. So for instance, problem number 1 says, what was the total revenue for both stores in 2018? Well, if I look at 2018 right here, this bar, when I look at both of the stores together, goes up to this line, which is halfway between 80 and 120, which would be 100. And specifically, remember, that's 100,000, so I'll put those extra zeros on, revenue. Put the dollar amount on too. So a dollar sign always goes in the front of a number, so that would be $100,000 for both stores. Question 2, what was store A's revenue in 2020? Well, if we look at 2020 now, so here's 2020. So if I look at this bar, if I want store A's revenue, I'm looking for the dark part of the bar. So I only want to go up to where the dark part of the bar ends. And if I look carefully at that, it's at this one line, which is halfway between 40 and 80. So that would be $60,000 in revenue for store A. So store A is just the bar that is dark. Now, store B, if we wanted to examine that for another year, say 2021, we'd be going here, and we only want to look at the light part of the bar. Now you might start by saying, well, that bar goes up to halfway between 160 and 200, so it goes as high as $180,000 technically. But remember, store B is just the part of the bar that's light. So the total of the two bars is 180. Where the light part starts is here at 80. So it starts at 80 and goes to 180. So that would be 180 minus 80 would be 100. So that would be $100,000 in revenue for store B. So again, because the bars are stacked on top, when you look at them, you have to imagine that the entire bar is for both stores, and then you have to separate the bars out and maybe do some subtraction if you want individual stores' revenues in this case. So stack plots, one bar is stacked on top of the other, and because of that, you may have to do some calculations to find exactly where one of the two stores was at. Sometimes instead of a stack plot, you may have a bar graph where you show the revenue for store A and store B right next to each other, kind of right next to each other for every single year. That can actually be a little easier for people to see. But on the other hand, if this is owned by the same company, by having them stacked on top, you're able to see the total revenue for both stores all at once. So there's advantages of a stack plot and there's disadvantages, but it is a pretty common way of showing, especially when you have, in this case, 2 or 3 stores or 2 or 3 items that relate to each other. There are lots and lots of different types of graphs, and people can get quite creative with them. In particular, you will tend to see a lot of maps that relate to geographical data represented with maps. So you'll have a map of, say, the United States, where the data is shown through shading of the different states or the different regions of the map. You'll see this also for world data. So you'll see a map of the world and different countries shaded to represent data that has been collected for those countries. There's a lot of creativeness that can go into maps. So a lot of data can actually be displayed artistically through what are called pictographs. So they're not necessarily bar graphs, but there may be pictures that are kind of creatively displaying the data that's been collected. Sometimes pictographs can be a little tricky because the artistic endeavors or the pictures can get in the way of the data. But the point of those graphs is to kind of be striking and capture readers' attentions. And in fact, those graphs can be designed to be quite elegant or beautiful at times. And so people will actually sometimes put them on a wall and frame them because they can be so artistically done. There's a very famous map related to Napoleon's invasion of Russia that is quite a striking map and contains a lot of information in a really interesting way that relates to the places that were involved and the size of his army. And if you're into history, I do recommend you go ahead and take a look at that map online. And of course, speaking of online, there's a lot of things that can be done on online in terms of making graphs interactive. So a reader may be able to hover over a particular portion of the graph to get more information, or click on a region to gain more information about that subject. A couple of great websites to check out. The U.S. Census Bureau collects a lot of data around for the United States, and it actually has a specific site that you can search for particular types of data visualization, so graphics related to that data. Another website, 538.com, examines data from opinion polls related to U.S. politics, sports, and the economics. And each year they actually have a story where they list their favorite charts or graphs for that year. If you're interested in that, just do a search for 538 best graphs of, and then put the year you're interested in. And I think you'll be surprised at how intricate and kind of dense those graphs are, and interesting to look at, surprising. Sometimes graphs are misleading or confusing. That can be because the person putting the graph together has just not done a very good job. Sometimes that can be because someone wants to mislead you. So let's talk about things to watch out for when you are looking at a graph. Let's start with incomplete labels. Sometimes a graph will not tell you what the axis represents in enough specificity that you would understand them. For instance, here we have a graph related to revenue for different flavors of ice cream, maybe for a particular store, but it doesn't tell you what store. But the worst thing, though, about this graph is that when we look at revenue, it's telling us that the vertical axis represents revenue, and we see the vertical axis goes from 0 to 12. Are those revenue values in dollars? Are they in hundreds of dollars? Are they in thousands of dollars? Are they in billions of dollars? Are we talking about an ice cream stand that your neighbor's kid has put together down the street? Or are we talking about a major ice cream company like Ben & Jerry's? So we don't know because there's not enough information here. And in particular, it's not telling us what this revenue is in terms of. It's not even telling us if it's dollars. Maybe this is revenue on ice cream from Bolivia or from Russia or from Zanzibar. Who knows? The other thing to watch out for is just in general, labels that are totally missing and no information. So here I have a graph about the pain relief benefits of, we're not sure what, but it's talking about a brand name for one bar and a generic brand for one bar. This might be something in an ad, but there is absolutely nothing on the vertical axis to tell us what these bars represent. Is it better that the bar is high, or is it better that the bar is low? We don't know anything about that. And in many ads, they may put together bars that try to emphasize something without giving you enough information to actually know what is that emphasizing. You can also have scales on your axes that are simply misleading. There's nothing wrong with it, but they can mislead. Like this example, revenue by product category. So I've got kites, toys, and games. This is probably from a particular store that sells to kids. So we've got revenue in hundreds of dollars. That's good. But when we look at these bars, just the way they're currently drawn, the toys looks really high compared to kites. In fact, it's almost 4 times as high as kites. So your initial impression might be that there were a lot more toys than kites sold. Okay, but let's look more carefully at the scale for revenue. Revenue here isn't starting at 0, it's starting at 40 and going up to 80. So the bar for kites goes to 50, so that means there are 50 $100,000 being sold to kites, and then the bar for toys is 80,000. So actually they're not so different. There was an impression that the toy sales were just as high or 4 times as high, but that's actually not the case. Kites are actually more than half what we have for toys. So this is an example where the scale has been designed to try to emphasize smaller differences, make small differences seem larger. They haven't lied, but it can kind of be misleading if you don't look carefully at what the scale is. A better way might be to show this where the bars are coming up to heights where you start at 0. 0 in this case still to 80, but my height for kites would go from 0 up to 50 here, and I would have that bar for kites, and my toy bar would go up to 80. And my bar for games would go up to 70. So what you see then is you do still have differences, and toys is still the highest bar, but it's not overwhelmingly the highest compared to what it seemed like over here when we weren't reading carefully. The other thing I'll say just in general is that pictographs, which tend to be very artistic graphs, can often have so much artwork in them that the data becomes lost or it becomes hard to follow. Sometimes when a graph is too busy, it can be hard to interpret.